See, now this is the second, like ninth one, right? Yeah, that one. Like I have written in shortcut. Okay, this is admission table. This is application ID. This is student ID. This is course ID. This is department. This is what they say, bro. Fees category. This is scholarship amount. Okay, I have written in small, so time will be less. See, it is similar to previous one as I explained. Okay, see the left right part. CID is there, right? Just click there. Next, what is there? Depth, right? Click. Now it is FC, right? Like it. There is SCA. So click it. Joe, forget this. Okay. These two are the candidate key now. Okay. Like start. Okay. Now let me now like see using like take application ID, sorry, AID, and SID. These two are the pras candidate key, right? Just take this both. Okay, like you should see like just calculating candidate key. Okay, just start it. Next, using AID, what you can take at CID and depth, right? Just write like using this relation, just write it here. Using this you got AID. SID is already there, so and you can get CID and depth. Now using CID you can get the scholarship amount also. So you just write using CID this, you will get AID, SID, depth and SA. Okay, now using this SID also, like now you have SID, you can take FC also. So just again write, like you should write full letters, not like this shortcut in exam. Okay, I know it will take time, but you have to write S and FC. Okay, since this is equal to this, so we will conclude that these two are the primary key, because using these two you can find anything in this. So AID and SID, like make this as a one set. Okay, this is the candidate key, and you should write like this is prime, right? Prime attribute, like right? Primary means using this unique, using that you can find anything in this one row or table, similar like that. Instead not primary, and you should write this 4 you should write here, this 4 you should write here. Okay, non-primary. Now see, in the question they ask, right, determine, like identify all quantity, all candidates over. Now go to the second part. In the question they have said determine the highest normally form of relation. Like they are asking like what is now what is the highest form it can go. Okay, the thing is, now check 2NF. What is 2NF says? 2NF says like no partial dependency. Okay, if it is true, then you have to go to 3NF, check it. Next for BCNF and all. Let's see, is it 2NF or not? Like you say, let me again explain. In previous video I think I made mistake. Like see, here using AID you can get CID, and using SID you can get FC. See, like this using like things using, like you have, like using half of the candidate key, you have chosen AID and the SID as primary key, right? Using join, if both join then only it is candidate key. But here using this only half of the candidate key, partial means something, like if this is fish 5 fingers or one part, means like if I don't have this, like similar, like I have everything. Okay, if one is not there it is partial, like that only. Using half only you can get this, like okay. And similarly it is not 2NF. Okay, because here using AID is there, by using a half of the candidate only we can find CID. Using half of the SID is also half, right? So using that you can get FC. So it is not. So you should write, like you should write that, like AID, like you should write full. Okay, you can get CID and debt, and using student ID we can get FC. So no partial depend, like it is partially dependent. Sorry, partially depend, partially. This is also dependent. Okay, using half only it can be taken, so it is not. Okay, this is second one. This you should write, um, partial dependency exists. The relation fails the 2NF state, so it remains 1NF. Okay, now see, now that is third. Now you have to convert 2NF, like it is 1NF. Now you have to convert it to BCNF, right? So first 1NF to 2NF you should convert. 1NF, what is say, it says that no partial dependency. Like where is the partial dependency? One is either I write this two as the partial dependency. So to make it 2NF, it is very simple, bro. It is happening this because, like you see, AID, you can get CID, and also what we can get, you can get debt and SA. Okay, to make it non-partial, what you will do, just take this, make this as whole, like one table. Okay, like you're using this. Okay, you will just write it like, yes, which is scholarship amount, and write it like here, and make it an separate table. Simple. R1, you take AID and course ID and department and scholarship amount. Like using this AID only, you can find CID also, debt ID also, and scholarship amount also. Okay, then there is no partial dependency. Now another thing is student. Next, student ID. Using that you can get this one as it is in question. You can find the fees category. Okay, fees category. And the next one is, as I said in previous question only, you should just write the candidate key. AID and SID are the candidate. A is admission ID, S is student ID. You might know by now. Okay, now it is become 2NF because there is no partial dependency, because we separated the candidate key into separate tables. In that table there is no partial dependency. Okay, like that. So it is 2NF now. Now we need to convert 2NF to 3NF. To convert 2NF to 3NF, see, the main rule is to remove partial dependency. Partial dependency. So what you will do, like where is partial dependency? Yes, see, in question only it is there. You can see, using AID you can find CID and debt, and using this CID you can find SA. So like using AID you can find CID, and using CID you can find scholarship amount. So this is called partial dependency. As I said, if course ID gone, what will scholarship amount do? No, same applies here. Just separate it. Simple as that. Um, this AID, CID all will come under here, right, in the first table. So we will just separate it. First we will do like R1A table. In that we will add just course ID and scholarship amount. Like using CID you can find SA. Okay, and here we will separate it. Using AID we will find debt and course ID. Okay, simple as that. Okay, like in here the CID doesn't depend on, because there is no element here only to depend, it is in another table, right? That's all. Okay, now we have to convert it into BCNF. So let's check. Okay, there are like one table, two table, three table, four table, right? Here see, CID. Using CID, can you find the another elements in the table? Yeah, you can find the scholarship amount. So R1A, you can write R1A is like in R1A CID to SA. So CID is super key. So it's pass. Like you can write anything, like you should just show that is successfully done. So in R1B you can say AID is passed. In R2 you can SID, and here AID. Using this you can you find another elements? Yeah, you can find. So that is like BCNF. Now see anomalies. Anomalies is like simple. Let's see. Anomalies means, see, when the table was 1NF and now it is BCNF. So you should say what was disadvantage was in 1NF. Now it is not there. There are three. One is insertion anomaly. Let me write it fast. See here, like first is insertion anomaly. Like you see, now you have to add an course ID. Like think just, okay, you have to write this in your own words. Course ID and the scholarship. Okay, here see, it is in question only. Like to add that, see, the course ID and admission ID. You have to add both. Sorry, not course ID. Like for scholarship amount, sorry, SID and admission ID, you should add both. So it will become an primary key, right? But think here, like if any student is not as attended, it will be null. But the primary key cannot be null, right? So if course ID and scholarship ID should have any value, means the student should apply, then only they can do that. So like there come an error, right? Yeah, that one is called insertion, because we can't insert the course ID and scholarship amount. Okay, next is update anomaly. Think like for this student you get scholarship amount as 100. Okay, and there are 500 students, you give all separate because all are in one table only, right? You give this student 500, this student 500, this two one, like 100, and you give 100 for everyone. Next time what you think that you should raise the scholarship amount to 600, and you see that you have to go to each row and update it, and that is very, like, it is not manageable. If it is 5000 you can't go, right? You should write a separate query for that. So the update anomaly. Next is deletion anomaly. Think if a student, okay, like join a course, okay, now it has a course ID. Next what they do, it cancels the application, okay, and what the thing is, you delete the course ID and its scholarship amount. Okay, the main thing happen is that there is a chance that this you delete the course ID, right, and scholarship, it might delete every other student's data, and that's called deletion anomaly. That's all, bro.